Alright, this lesson is going to be a short one on reducing radicals, both positive and negative with imaginary numbers. So let's say you had something like the square root of 36. That's fairly easy because 36 is a perfect square, so you can reduce it simply by writing equals 6. However, if you had a number like, say, 50, which is not a perfect square, you would have to think about what the factors of 50 are that have perfect squares. So 1 is a perfect square, and sure enough, 1 times 50 would work, but that's not going to help us reduce it at all. The next perfect square is 4, which does not go into 50. Then there's 9, also does not go into 50. 16 does not go into 50. 25 does go into 50, however, it's 50 times 2. So we could write this as the square root of 25 times 2, which is the same thing as the square root of 25 times the square root of 2, which is 5 times the square root of 2. So that reduces the radical for us. For another example, we could look at the square root of 27. Again, 27 is not a perfect square, so we want to look at what perfect squares will go into or are factors of 27. Again, 1 is always going to be a perfect square that goes into every single number, but it doesn't help us reduce at all. 4 is the next perfect square, but does not go into 27. 9 is a perfect square, and in fact is 9 times 3 is 27, so we could rewrite this one as the square root of 9 times 3, which is the same thing as the square root of 9 times the square root of 3, and the square root of 9 is 3, so we end up with 3 times the square root of 3, and that's our final answer. We can't reduce the 3 any further because it's a prime number, so it stays as is. Here we have the square root of 40, and if we think about the perfect squares that can go into 40, we know that 4 is a perfect square, and 4 times 10 would give us 40. So we could rewrite this as the square root of 4 times the square root of 10, which would be, the square root of 4 times 10, which is the same thing as the square root of 4 times the square root of 10. And the square root of 4 is 2, so we get 2 times the square root of 10. Now 10 is not a prime number, so we can reduce this further. If we think about the factors of 10, though, it's 1 and 10 and 2 and 5. And none of those numbers are perfect squares. However, we are going to reduce it by writing it as the square root of 2 times 5, because both of those are prime. So then our final answer would be 2 times the square root of 2 times the square root of 5. So since the two numbers underneath the radicals, or underneath the square root signs, are both prime, now we can say that this is the most reduced or simplest form, and so this is our final answer. Now, reducing radicals when you have a negative number are going to result in an imaginary answer, because you can't take the square root of a negative number with the reals. So you have to use an imaginary number. So in this case, we're going to rewrite negative 16 as 16 times negative 1. This would give us the square root of 16 times the square root of negative 1. The square root of 16 is 4, and the square root of negative 1 stays there, or you can replace it with I, which represents the imaginary number. And just in case you didn't remember, I is equal to the square root of negative 1, and it is the imaginary number because, again, you cannot take the square root of a negative. But this 4I would be our final answer. Another example here, if we have the square root of negative 49, we could rewrite that as the square root of 49 times negative 1, which would equal the square root of 49 times the square root of negative 1, which equals 7 times I. Now, in both of the examples I've done so far with negatives, it's been a negative perfect square. We can do this, though, as well with a number such as, like, negative 18. And so in this case, 18 is not a perfect square, but we can still do the square root of 18 times negative 1. I don't like the way that looks. Times negative 1. Alright, which would give us the square root of 18 times the square root of negative 1. Now we need to reduce the square root of 18, so we need to think of what perfect squares go into 18. And in this case, 9 goes into 18, so 9 times 2. So I can rewrite this as the square root of 9 times 2. And then the square root of negative 1 is going to become I. So I end up with the square root of 9 times the square root of 2 times I. And the square root of 9 is 3. So it's 3 times the square root of 2 times I. And that would be our final answer for this problem over here. So you can see that whether you're reducing with a positive or a negative, you still want to make sure that all of the numbers underneath the radicals are prime, or they can't be reduced any further. Alright, hope you enjoyed.